Okay, good day again. Let's continue talking about Chapter 5, which is exponential growth. In Section 5.2, we talked about a really specific letter. We talked about E, which you might know is the fifth letter of the alphabet, but in this section we're going to talk about a mathematical irrational number that's properties are very similar to that of pi, and its derivation is very close to that of pi. However, we're going to talk about its exponential properties in relationship to what we talked about in 5.1, which is the exponential growth. So first off, let's again get started with our learning goals. What do we want to learn today? Let's take a look at the PowerPoint. Today we want to be able to explain what E is, where E comes from, where we get it, be able to discuss the domain, the range, the intercepts, the asymptotes of translations of y equals e to the x, which again, building on things we've talked about in other sections, we move it left, right, up, down, we stretch it, we shrink it, we reflect it over the x or the y axis. And then we talk about something that really you learn a great deal about in calculus, but we're going to talk about the average rate of change, the instantaneous rate of change of a function. We're going to apply that to y equals e to the x. So we cover a lot in this section, even though we're really only introducing one new term, applying it to things we've talked about in the past. Let's talk about what is E first. E is definitely something that was discovered, and then its properties are what made it famous. We're going to learn one of them today. But as we talk about in calculus, as you take 172, either next term or the following term, E's properties are what make it interesting, as opposed to just just what became about it. It's the definition of E. The limit as x goes to infinity of the quantity 1 plus 1 over x, all raised to the x power. Now let's take a look at what that approach is and what value we could use for E as we take a look at it in some equations today. So let's go to the calculator. Let's type in our equation, which is the quantity 1 plus 1 over x raised to the x power. As that's coming up, let me flip back to the PowerPoint again. Possibly the first time you've seen this notation, but limit means as we continue to make x larger and larger and larger, what does the value of that function go towards? What does it approach? What's it lean towards? Now let's go back to the calculator and take a look. We can see asymptote at x equals 0, which we expected because we have 1 over x in the equation. Let's take a look at the table for this one. And we see as x is going to 10, we're coming to 2.5, maybe 2.6. Let's change our table. And let's start at 0. And instead of going by 1, let's go by 100. See what that gives us. Let's go back to our table. And actually, I put in 1,000, but let's go back and put in 100. There we go. Small little lag there in the calculator. Let's look at the table. As we see as x values increase, 2.7, 2.71, let's keep going. Then as we approach that last digit of what our calculator shows us in there, as we go to 4,002.71, let's see if it'll even keep going for us. Yep, as we continue to go towards infinity, 2.718. And yep, there we go, 2.781. Sorry, just a small little lag behind in the computer here. So real quick, let's go to the dot camera. Your instructor will have a level of precision that they want E to go to, but for our class for today, we're going to approximate E to be 2.718. We'll go out to 3 decimal points, out to the thousandths place. Now, just like pi, you could keep going on forever. I'm sure there's people that have brought this number out to 5 pages, 10 pages, 500 pages of decimal points after 2. But for our class, we use that as our approximation. So it's between 2 and 3, closer to 3 than to 2. And again, the limit is x goes to infinity of 1 plus 1 over x, all raised to the x power. Let's flip back to the PowerPoint real quick. So that's what E is, that's where E came from. Has some cool properties. One of them we'll get to talk about today when you take 172. We'll talk about a few more. Let's take a look at the graph of y equals e to the x. Let's again look for those same things we've been looking for throughout this book. Domain, range, asymptotes, intercepts. And then let's talk about how it's related to what we talked about yesterday. So let's go to the grapher. Let's go, in this case, I'm going to use Geometry Sketchpad. If you have a graphing calculator, feel free to use the same thing. Let's show the grid, and let's put in a function here. Values, e to the x. Hit OK, there's our function. Just real quick, I'm going to go to the TI, because the question always comes up, where's E? And the one that people are going to use is this green E right here, and that just stands for the letter E. That's actually not the value of E. To get E into your calculator, you actually have to hit second and then the LN button, which is something we'll talk about in this chapter. That's how you get the E function to put it into your graphic calculator. Second E to the x power. You can see the table and the graph over here as it's looking at it. If I want to look at the sketchpad, this should look fairly similar. Remember that base function we used yesterday was y equals 2 to the x power. E being approximately 2.718 looks very similar. In fact, let's talk about its properties. The domain, again, all real values you could plug in from negative infinity to infinity. Anything you plug in will get you an answer out that's a real number. The range, again, we can see we're going closer and closer to 0 as x goes to negative infinity, closer to infinity as x goes to infinity. So the range of our function, again, from 0, not including 0, to infinity, got just a y-intercept at 0, 1. And again, asymptote, because it will never actually hit 0 at y equals 0. Let's write those on the doc cam real quick, get those in your notes. If we could switch to the doc cam real quick here on campus. There we go. Properties of the graph of y equals e to the x. Again, our domain, all real numbers, negative infinity to infinity, or you could write all real. The range from 0 to infinity. The intercepts. We only have a y-intercept, and it's at 0, 1. And our asymptote is at y equals 0. Now, when talking about this very similar properties, the asymptote's the same, the intercept's the same, the domain's the same, the range is the same, because e to the x is a subset of our exponential functions. It's one example of that. Now, as you've noticed probably throughout the pre-calc series, as soon as we introduce a new function, we talk about translations of it. So we're going to hit that, hit transformations, translations. Let's take a look at an example on the PowerPoint, and let's go for, let's use the graph of y equals e to the x to graph the function y is equal to negative e to the x plus 2. As you're taking a look at this one, just want you to partner up with somebody next to you. What are the transformations or translations or reflections that occur in this graph? What are the translations, transformations, or reflections that occur in this graph? Let's throw over to the doc cam real quick and let's take a look. So we have y is equal to negative e to the x plus 2. Anybody on campus, what translations, transformations, or reflections occur on this? Okay, heard one. Okay, there's a reflection. Is it through the x or through the y? Don't know. Okay, let's talk about this. If it's a reflection through the y-axis, is the negative before the function or after the function? Okay, well, is the negative here before the function or after the function? Okay, it's after. Okay, so this is a reflection through the through the x-axis. Okay, silly question, but when we take a look at the graph on this, are all the values going to be positive or all the values going to be negative? Okay, good, negative, yep. Why? Before our reflection, all our values were positive. Once we reflected, all the values end up being negative. Okay, now plus 2. 9 out of 10 students are going to say, okay, 2 to the right. Correct, not correct? Okay, not correct. Now, why isn't it correct? Yeah, why would he have asked the question if it was correct? Okay, why is it not correct? Let me ask you a question. How could you write a translation, reflection, transformation of this that it would have the same effect on y equals x squared? How can we take y equals x squared and have the same effect as this function has on e to the x? Okay, we'd have to have a negative out front. Now, would you put the plus 2 in the parenthesis or outside the parenthesis? Okay, good. In the parenthesis, because it's before the action. It's before the action. So we have to remember, when it's inside, it's opposite. So does it move it 2 to the right or 2 to the left? Moves it 2 to the left. So in this case, the plus 2 moves everything 2 to the left. It's inside the function, it's before the function, so it's opposite. So we have a reflection through the x-axis. We go 2 to the left. So let's take a look. What will our domain be of this new function? Domain stays the same, negative infinity to infinity. What's our range of this going to be? Okay, it reflects it through, so it's going to be through the x-axis. Okay, so it's going to go from negative infinity now to 0. In other words, 0 will be the highest value that we almost reached but never actually hit. Where's our intercept going to be at? Where's our intercept going to be at? Now, I heard somebody say 0, negative 1. Let me ask you a question. Does this have an effect on the intercept? Okay, well, not hearing any responses. Let's take a look at the graph. Let's go flip over to the computer real quick. And here's our original function, and I am going to dash that one. Oops, got to select it first. Let's dash that one. There's our original function. Let's put in our new one, see what happens. So we have y equals negative e to the power of parenthesis, and then we had x plus 2. Okay. Question. Now as we look at that, definitely our intercept's not at 0, negative 1. In fact, the point it goes through at negative 1 is negative 2, negative 1. And let's plot that point real quick there. Oops. There's negative 2, negative 1. What happened to our intercept? What happened to our intercept? Yeah, it got moved way over. In fact, what affected it? Okay, yep, the translation. Yep, it affected it. Moved it 2 to the left. So let's take a look. We might actually even have to use the equation for that. Let's plug it in here. Oops. We have negative e to the power of x plus 2. Now, let me just start. There we go. Negative e to the power of 2. And then let's reset our table. Remember, we have going up by hundreds. Starting at 0, go up by ones. Okay, what are we looking for here? We're looking for what input value gives us an output value of what? Okay, we're looking for at 0. What's our output value at negative 7.38? Okay, there's our intercept. Let's flip back to the back camera.